Hi, this is Jay McClellan, and today I'm going to build a welding cart to hold my new combination TIG welder and plasma cutter, also my older wire feed welder. I'm going to build it with a lot of storage using this rolling storage cart full of drawers, and I'm going to build it with a large work surface on top. I designed the welding cart using SketchUp software, and I'll post my SketchUp project file to my website at brainright.com with a link to that in the video description, so you can go download the SketchUp project file if you want. I like to use the layers feature of SketchUp in order to be able to turn different features of the drawing on and off. So I'll turn off some of the features that we don't need to look at right now. The unit is built around this formerly rolling tool cart that I purchased, and unlike many welding cart designs, there's no additional structure. So the bottom part of the welding cart is a rolling trolley essentially, and then this set of drawers sits on top of it, and the top mounts on top of that. The tool chest that I'm using is rated for 1,100 pounds, so it's plenty strong enough to take the weight. And by not having any additional structure, number one, it saves me the time and expense of building the additional structure, but number two, it also allows this top to move independently as it expands and contracts with heat. I'm going to support the steel top above the tool cart using these square steel tubes, and these are hitch receiver tubes made for 2-inch square trailer hitches. And I'm going to use this so that I can use them to mount various kinds of accessories. For example, a bench vise like this, and these support tubes in back that I can use to support lights and cameras and so on. So it's a fairly versatile arrangement, and it also allows me to put receiver tubes like this at other parts in my shop so that I can use these accessories I'm making in other ways. I'll start this project by building the rolling base that supports the tool cabinet. Once that's built, then I can place the cabinet onto it, and then I'll set out the hitch tubes and the steel top, get that assembly welded up and placed on top. Then I'll build the rack that holds the welders on the right-hand side. And then finally I'll place all of the components onto the cart to complete the assembly. The rails are cut from steel angle that's 1.5 inches across and 1/4 inch thick. Well, I've got the frame all cut out. I've got the corners beveled and ground off the mill scale so that I've got a nice clean surface for welding. The fit up is pretty good. I got a little bit of gaps here and there, but not too bad. So, time to TIG weld it. Here's my first attempt at shooting video of welding using an auto-darkening welding helmet filter in front of the camera lens. It came out okay, but it's a bit dark, so I'll work on that. But you can see that this particular weld on the corner, I'm not using any filler, just the torch to melt the corner together, and it came out pretty good, I think. Here I'm welding the butt joint on the inside of the corner, and I have the welding filter in front of the camera turned up a bit so you can see better. I'm dipping the rod about once a second, and this is at about 120 amps on the TIG torch. So all in all, I think this weld came out reasonably good. There's just in one spot a little bit of porosity, but nothing that'll cause a problem. The hardest part in welding the vertical inside corner was getting my hands and the TIG torch and the filler rod and my head and the camera all kind of in there at once without blocking the view of the camera. So you still can't see real well, but I welded up from the bottom, and I could tell that the weld wasn't real smooth, and so I just reversed direction at the top and ran the torch back down the inside corner to smooth out the weld without adding any additional filler rod. And in the end, I think it came out looking pretty decent. Well, I finished TIG welding all of the joints I can reach on the top, and they came out pretty decent. Full disclosure, this is my first project using a TIG welder, so don't look to me for instruction on the best way to do TIG welding. I'm still a beginner, and I think the welds, they certainly don't look professional, but they came out halfway decent, and they're plenty solid. They're decent smoothness, and they have a little porosity here and there, but not too bad. So for a first attempt, I think it came out pretty well. And now I'm going to flip it over and weld the bottom sides. I need some strips of steel 2 inches wide and about 9 inches long to weld underneath, so I'll cut the strips using the plasma cutter. If you're going to use a plasma cutter, it's a good idea to do it far away from any flammable materials. So if you're cutting outside over something like a gravel driveway is a really good idea. However, like me, you might have limited choices as to where you can do the cutting, and you may have to cut in an area where you have some flammable materials like wood chips or leaves. And so, helpful safety tip: if you have to do that, spray it down first with water. That way, the plasma is very unlikely to ignite a fire in the surroundings. Now watch the following clip to see what happens if you don't do that. Unfortunately, I chose a bad camera angle at this point, so you can't actually see the tip of the plasma torch, but as it turns out, the more amusing part is in the background. My welding helmet gives me tunnel vision, so at this point I couldn't see the fire that you can see in the background. I'm glad I caught it on camera, but watching through the welding helmet, I really didn't have an idea that things were burning because the smoke was blowing away from me, so I didn't notice until the end. Now there's an interesting development. Not a big deal, but I guess I better put the fire out. Time to cut another 2-inch strip. This time I've got the area well soaked with water, so I think it'll go a little smoother. I also have the amperage turned up a little bit. I didn't get a really good cut on the first pass, so I turned the amperage up all the way, and we'll see if that cuts better. To notch the ends of the cross supports, I cut them with the chop saw down as far as I could, and then I'm going to cut the rest of it with the plasma cutter in 2 passes to notch it out, and then I'll grind it smooth. I got all my filler pieces cut with the plasma cutter, and then I went back and ground off the plasma cut edges to get a nice clean metal surface on the edges where it was cut. And then I also ground off the mill scale all the way around wherever there's going to be a weld. So the fit up of these is pretty good. There's a little bit of a gap, but not too bad. And then I cut the ends of the cross beams that are going to support the cabinet. So they're beveled and cut so they fit in just like that. So now that I got all the pieces cut, I've got all the surfaces that are going to be welded clean to mill scale with nice clean metal. It's ready to TIG weld it. I'll start by putting some tack welds on to hold everything together, because of course I don't have enough clamps for the whole thing at once, and clamp it up as well as I can, get it all tacked up, and then I'll go back and TIG weld the joints. Here's the completed base frame. It's all welded up, all TIG welded, and TIG welding is kind of a crazy choice for something like this in terms of just getting it done. Wire welder certainly would be much faster, and it doesn't need every inch of all of the seams welded to have sufficient strength either. But I did it this way because I wanted to practice. So I got a lot of practice using my new TIG welder, and some of the welds I think came out actually looking sort of competent, and a lot of them came out looking less than competent, but that's okay. That's what practice is for, and they're certainly plenty strong. I'll weld these panels in place using a wire feed welder with flux cord wire, because it'll be a lot faster than TIG welding, especially because I don't need to clean off all of the mill scale in order to use this type of wire, which I would have to do with TIG welding. Here's the finished bottom frame ready to paint. I got all the panels welded on, I drilled the holes for the casters, and then wire brushed all the exposed surfaces with a wire brush on the angle grinder to clean off mill scale and crud, etc. And then wiped the whole thing down with mineral spirits. So now I'll give it a coat of primer and then a couple of coats of paint. Well, I got the base all painted, and I attached the casters to it. These are not the original casters that came with the tool cart. They're a slightly smaller diameter. I think they're 4-inch casters. The cart is attached at the 4 corners, bolted in with bolts that go into the holes that were for the original caster. So it's really solidly attached. Now it's time to build the top from a sheet of 3/8-inch thick steel. I would have preferred 1/2-inch thick, but this is what was available in the used section at the local metal store. So I made a template out of plywood for the corner that I need to cut out on this end, And I need to cut this corner in order to make room for the argon cylinder and possibly a second cylinder that I want to store on the cart. As you can see, the plasma cutter is not cutting 100%, and that's partly because I'm not able to move it real smoothly along here. So every time it kicks up and you see the sparks shoot up to the top, it's not cutting 100% through. So since it didn't cut all the way through on the first pass, I'm going to have to do a second pass and run it down all the way, and it should cut all the way through on the second try. I used several different abrasive devices to try to get the mill scale off this piece of steel, and nothing really worked very well, so I'm going to etch it off with the hydrochloric acid. This acid's not as nasty as some kinds of acid, but it still warrants caution, so I'll be wearing gloves and a full face shield. My first attempt to remove mill scale from the plate didn't go very well. I applied muriatic acid and I scrubbed and I scrubbed and I scrubbed and I worked at it for about 15 minutes, and the scale was kind of sort of coming off, but largely was not. But eventually I realized that the problem was I had grease on the surface, and so the acid was not really reaching the scale itself in all areas. So that was on the other side of the plate, which will be the bottom. The plate is now right side up. So I'm going to do the top now, and the first thing I'm going to do is degrease the surface with a degreaser. I'm using TSP PF, which is like trisodium phosphate without the phosphate. It's a substitute for TSP, but it's a fairly powerful degreaser. And when I tried that on the other side, I found the acid worked 10 times better. It really works much better that way. So I'll go ahead and do the degreasing, and then I'll apply the acid with it still wet, and just apply a little bit of acid I'm going to apply it full strength to the wet surface, so it'll get diluted as I'm applying it to maybe 50% strength. Here we are after over half an hour of soaking with the acid, and at some point it seemed that the remaining scale just wasn't really changing. It wasn't coming off anymore. And so I've degreased it again, and now I'm going to hit it again with acid, and I think this time it should take off the rest of it. So all the mill scale has been removed after 2 cycles of first degreasing it with TSP PF, then a diluted solution of muriatic acid for anywhere from 10 to 20 minutes. I'm going to neutralize the acid with baking soda, and once it's pretty well neutralized, wash the whole surface down with water, get it nice and clean, and then I'm going to use my leaf blower to quickly blow dry the entire surface as quickly as I can, because if it's left damp it rusts very quickly. And then as soon as it's dry, spray it down with WD-40 and wipe that in real well. These square steel tubes will sit between the work surface top and the top of the rolling cart. And this is receiver tube. It's made for trailer hitch receivers. And unlike most square tubing, it has the welded seam ground smooth so that a 2-inch square tube will slide just nicely inside and smoothly. And I have it drilled so the geometry is basically the same as a trailer hitch. And these will sit about like this on the top. This one will sit out to the side like that. And the back pieces will sit like that. So I'll have 5 hitch points all the way around for mounting various kinds of tools and accessories under the tabletop. It's designed so that these don't butt up real tight to the edge of the table, but they have a little bit of space in here, and there's a little bit of space in here. So the whole assembly is allowed to float a little bit, and rather than use one continuous length of tube on each side, I'm using a separate length on each corner, and these will only be welded at fairly small points because I want the whole thing to be able to expand and contract and move a little bit without being tightly attached to the corners. First I'll weld these 2 pieces that'll go on the left-hand side of the tabletop. And I don't want any spatter to get in the mounting hole for the accessory, so I'm going to cover it with a piece of foil just to keep the spatter out. And I'll put a couple of tack welds on each side and then go back and weld it up. I have these 2 tubes joined, and now it's time to weld them onto the underside of the tabletop. So this is my 3/8 inch thick plate for the tabletop, and this will be the front left corner when it's flipped over. So I've got these clamped down, I got them squared up, and I'm going to put fairly small welds on each one. My main concern in this is to minimize distortion of the tabletop. These are trailer hitches, but they're not actually going to be pulling a trailer, so I don't need a whole lot of strength in these welds. And so I want to make them strong enough that they're sturdy, but not so strong that it causes distortion in the tabletop. And I also don't want to make them so long that the tabletop would distort even just from heating up while I'm working on it if I'm welding a project on the top. So I'm going to do just about a 2-inch long weld on the side of each of these tubes right under the mounting holes. And I got rid of the aluminum foil, and I'm using these little silicone plugs to protect the holes from weld spatter. These are made for powder coating, but they work pretty nice for this. So I've got the holes closed up, and I've got this little 2-inch length of TIG welder filler rod down here so that the fillet won't have to bridge quite as deep a gap. And I'll put some tack welds all the way around on each of those to hold everything down, and then I'll come back and put a continuous fillet weld on each one. So I think that looks pretty good. I went reasonably fast, so I don't think I got very deep penetration into the steel, but that's okay. I actually don't want very deep penetration for this weld. It's going to be plenty strong for holding up something like a bench vise, and so I wanted to minimize the heat input, and I think it worked out okay. I can't see any distortion in the top, and it doesn't really even look very oxidized on the other side. So hopefully that struck a good balance between making it strong enough for the purpose and not putting any more heat into the part than necessary. These pieces are 9.5 inches long, but I'm still only welding them a couple inches under the mounting holes for the hitch tube. I'm not going to weld them back here. This is the part that's going to sit on the cart, but I don't want to put the weld any longer than I have to, so that as the top heats up, if I'm using it, it won't distort any more than necessary. Well, I got all the tubes welded on. I got the bottom, which will be the underside of the top, cleaned up nicely, so it's all completed on this side, and all I have to do is flip it over onto the top of the cart. It weighs somewhere between 170 and 200 pounds, so it's a little bit heavy to deal with, but I'll tip it up slowly and carefully. And at this point, I'm actually kind of glad I went with the 3/8 inch thick steel instead of 1/2 inch, because that'd be a lot harder for me to deal with. I made these L brackets to secure the top to the cart. That should hold it down quite securely, but they'll have enough flex to allow the top to expand and contract a little bit. And I've got them clamped exactly where I want them to the top, and I'm going to drill through these holes to mark the location, and then I'll put screw inserts in into the cart. These threaded inserts are also called riv nuts, and they install with a tool like this. It's very simple, just thread the riv nut on, insert into the hole, and compress. To weld the brackets onto the top, I have the cart wrapped in a fiberglass welding blanket to protect it from the spatter. I tried several different surface treatments for the top, and in the end, the one I like the best is just a simple random orbit sander with 60 grit paper. I don't want a real shiny finish, I want it kind of matte, but I do want clean metal for welding purposes, so I think this will work fine. It's simple, I've got dust collection on it, so all I'll do is sand it up and the top will be done. I welded up the frame to hold the welders and then painted it to match the rest of the cart, and it just sits in the side like this. Nothing more to it than that. That way if I want to change it around later or whatever, I can change it pretty easily. But this will hold the wire feed welder below and the new TIG welder on top. To supply power, I made this portable sub panel. It's a 6-circuit sub panel. I have one circuit with 50 amp supply for the welder plasma cutter combo, and then I have two 120 volt circuits for powering the wire feed welder and for various accessories, and then I have a couple of blank spaces and room to expand in case I want to add another circuit in the future. And it's connected to a 25-foot long power cord, 6-gauge, 50 amp plug on the end to connect to a range outlet. So I'll mount that on the back like this. Time to weld up the bracket that will support the tanks. So this is the underside, and I just have this piece that I cut scalloped for the curvature of the tank, and I need to weld it to this piece of angle iron. So fairly straightforward, and I'll use the TIG welder for this. This will be the first project on the new tabletop. I need a way to attach the straps that will hold the tanks in place, so I'm going to weld on these nuts into position. These are 1/4 nuts. I got the nuts welded onto the bracket. Honestly, I think they look pretty terrible. A number of problems I had. One is the breeze is coming up out here, and so my shielding gas was not really staying on the part very well. So I got some oxidation from that. I think I also got some oxidation and contamination from the zinc coating that was on these nuts. And I was careful to stay upwind and not breathe any of the fumes coming off. There's not much zinc on these nuts, but there's a little bit. The welding on the tank retaining bracket actually looked pretty good once I got it cleaned up. So I went ahead and painted and installed it, and I have a little length of split vinyl tubing just to prevent metal on metal rubbing on the edge of the tank, and then a strap to retain it. So it's quite sturdy, and I can add another strap on the other side for a second tank if I want one. Here's a rear view of the finished cart where you can see the TIG welder, the wire feed welder, my power panel, and a hook to hold the power cord, and I have some room for some extra storage down at the bottom. Here's a front view of the finished cart. I've got my work surface on top, 2 receivers here for accessories to mount, my storage drawers for all my tools, my 2 welders on the right, and a little bit of extra storage on the left, and then my tank in the back. I mounted the bench vise on a removable insert that I can put in any of the receiver slots around the corners of the table. And once it's in place, then it's held in place with a single bolt. I welded a threaded nut inside the tube, so the bolt just screws into that and bolts it to the side of the receiver tube. That's really, really sturdy once it's bolted in place. Before I mounted the vise, I ground off the bottom surface. I cleaned off all the paint, and I also cleaned off all the paint in the mating surfaces of the swivel portion of the vise and behind this jaw. So once I put in the retaining bolt to bolt it into the frame, I have a really solid electrical connection between the tabletop and the fixed jaw of the vise. And that way I can use it for welding projects without having to have an additional ground clamp, as long as I have the table clamped to a ground. Here's another accessory I made for supporting things like this camera clamp. It's just a piece of pipe welded to a hitch tube that I can insert into any of the receivers around the table, and it has a threaded hole, so once it's bolted in place, it's really, really solid for supporting cameras, lights, or any other kinds of accessories I might want to mount around the table. Well, that wraps up this project, and I'm looking forward to using my new welding cart and having a place to store all of my equipment and a good surface to work on. I hope you enjoyed the video. Thanks for watching.